So the last section of the topic is to do with volume. We're going to do one section on volume of prisms, and there is 3 formulas here for prisms, but then we're going to do another one on cylinders as well. Okay, so the 3 formulas that we have here for this lesson is the rectangular prism, and if you have a length, a breadth and a height, the 3 numbers around that rectangular prism, then the volume is equal to LBH, which is the length times the breadth times the height. If we have a cube, which means all the sides are the same length, and L is the side of the cube, then it would be L times L times L, which is L cubed. So B equals L cubed. You can still use the rectangular prism formula, and it works as well for a cube. If you have any other type of prism, like say a triangular prism, where it's a triangle on the front, you find the area of whatever the front surface is. That's what the A represents. A is the area of that. And then you times by the height of the prism going back. So that's kind of a more general prism formula for any prism. As long as you can find the area, you times by the height going through it. Okay, so our questions. Oh, wait, this bit first. Remember how we did length? And we had the 10, 100,000. Then we did area, where it's the 10, 100,000, but then they're all squared. Now we're doing volume, so if they're millimeters cubed, centimeters cubed, meters cubed, kilometers cubed, that means that these become powers of 3 on them as well. The 10, 100,000 pattern is still the same. It's just that we have to, because it's volume, we have to have that power of 3 on it. The other thing that we're going to do in volume is, because volume is measuring how much can go inside the shape. And a lot of the time, we want to know how much liquid a shape could hold, like a bottle of water or a water tank or a fish tank, those kind of things that hold liquids. So you don't measure liquids in centimeters cubed. You measure them in milliliters or liters, or those kind of units, which we call capacity. So there's a few different things here, but I basically bring it all back down to 1 centimetre cubed is the same as a milliliter. You think of those little wooden blocky things that you used to play with in primary school, these fine little 1 centimetre cubes, they hold 1 mil, okay? Whereas a metre cubed, which is quite big, you think a metre cubed this way, so metre this way, and a metre tall, that's not going to just hold 1 litre. A 1 litre thing is like your milk in the morning. That's way more, right? That is a kilolitre. So there is the 1,000 litres in there, or you can just go straight to a kilolitre. If you need to change between your capacity units, we're going to be using millilitres, litres, and kilolitres. They all work in lots of 1,000. So going from millilitres to litres, you divide by 1,000 going this way, and you times by 1,000 if you're going across the bottom. Okay, so question time. Question number 1. Find the volume of each of these. So question 1, what kind of shape is that? All the sides need to be the same if it's a cube. Yeah, it almost is. There's this sneaky 4 up here. So there's more than 3 numbers here. What 3 numbers should I use? If I use that process that I was using last lesson, we're just going to go down the side. So I'm going to use the 4, the 6, and the 6. We kind of go down the side of the shape like that. Or you find a corner and try and find the 3 different directions coming out of that corner. Okay, so that's going to be a rectangular prism, and the formula for a rectangular prism is LBH. Because they're all next to each other, it means that they're going to be timesed. It doesn't really matter which one's the LB and H, so I'm just going to go LBH down the side like that. And then I'm going to sub those in. So 4 times 6 times 6. And we put it in our calculator. And we get 144. This will be kilometres cubed because it is volume. Okay, let's do another one. Question 2. What shape is that? rectangular prism again. So I'm going to use V equals LBH again. I'm going to go down the right-hand side. This is going to be the L, B, and H. So L, B, H. Let's sub those in. L was 6 times... All right, so we're subbing in 6 times 12 times 10. And we're typing that in.
720.
Very good. What would the units be? Meters cubed. Good job. Okay, question 3. What kind of shape is that? Triangular prism, that's right. 'Cause you have a triangle on the front here, and a prism just means it's the same shape the whole way through. Okay, so it's not a cube, it's not a rectangular prism, so I'm going to use the V equals AH, which is my formula for any other type of prism. But before I can use that, I have to find out what the A is, which the A will be the area of my triangle. Okay, so I'm going to do that over here on the side. What is the formula for the area of a triangle? Look on your sheets. On the printout sheet, the extra sheet that you've got with all your formulas on it. That's right. So A equals half BH is the formula for our triangle. Now remember, the base and the height have to be joined by a right angle. So don't get confused by this 10 that's sitting here. The right angle would be there, because see how there's one over here? There would be the right angle there as well. So what two numbers do I have going here across the top and down that slopey one? What would my base and my height be? Not the 10. So we need that one and that one. 8 is the one going down. What about the one across the top? 6. The 5 is not in the right direction. Okay, so it's going to be half times 6 times 8, which is 24. So always find that right angle. So there's always going to be extra numbers on a prism like this. So you have to find that right angle so you know which one is the base and the height. Okay, so now I want to go to my volume formula. The area that I just found was 24, and the height of the prism is not always just, here's the bottom of the diagram, it's not always one that's going vertically up and down. It is the side length that is going away from your triangle. So if my triangle is here in the front, I'm drawing that in red, the side that is going backwards from that triangle would be this one here, which is the 5. The 5 would be the height of the prism. Okay, so you could rotate it around if you want, so the triangle would be sitting on top and there'd be 5 going down. Yeah? So it's going to be 24 times 5. What does that equal? 120 kilometres cubed. So this 10, I didn't even need it at all. It was just there as a distraction. Question 4. That is called a trapezoidal prism or a trapezium prism. You have a trapezium on the front, and then, so this would be my area that I have to find, this trapezium here on the front, and then the height going backwards would be that 8. But like I did last time, I have to find the area of that trapezium first. On your sheets, what is the formula for a trapezium, the area? Starts with a H. H over 2 bracket. That's right, A plus B, close bracket. Now, what are the things that I need to sub in? What is H going to be for the trapezium? We just want to look at that red trapezium. What is the height of the trapezium? The height is the one between the two parallel sides. No, that 3 is one of the parallel sides. So this 3 here and that one there, how long would that top one be? 6. So the 3 and the 6 are the A and the H. They're the two parallel ones. The height is the one going between them, which is that one in there. How big's that one? 2.6. So we're going to have 2.6 over 2 bracket. The A and the B were the 3 and the 6. Close the bracket, and we have to work out what that is. So 2.6 over 2 bracket 3 plus 6, close bracket. You guys get 11.7? That's kilometres squared because that's the area. When I want the volume of a prism is V equals AH. The area is the 11.7 that I just found. The height is, I told you way back at the beginning of this question, which one was the height? Going away from the trapezium. The 8. So 11.7 times 8. Which is 93.6. And that is kilometres cubed, but it's now the volume. Okay, question 5, back to a little bit of an easier one. What shape is that? Rectangular prism, so it's V equals LBH. The LB and H are going to be the 3, that's right, those 3 going down the right-hand side. So we go LBH, and we're going to sub those in. 10 times 9 times 11. Wasn't it 900, what, 10 times 9 times 11? And that would be kilometres cubed. So rectangular prisms and cubes are definitely the easiest because it's just sub straight into your formula. It's any of the other ones where you have to find the area first and then the volume. So this is another one of the V equals AH ones. What am I going to have to find the area of first? The triangle. Okay, so here is a triangle. The formula for the triangle is A equals half BH. What is the base and the height of my triangle? Find the right angle. Yes, and? Very good. Half times 8 times 6, which equals 24 centimetres squared. Okay, then for the volume, V equals AH. My area was 24. What is the height of my prism? It is the 10. Yes, good. 24 times 10, which is 240 centimetres cubed. Okay, question 7. Find the volume of the tank below. Well, that seems easy enough. But this one is special because it says, what is the answer in litres? So we're going to have to do an extra bit where we're going to have to turn it into a capacity unit. So first of all, you do the volume just like we've been doing. That's a rectangular prism, which means I want to use V equals LBH. So my LB and H are going to be the 3 numbers. I've only got 3 numbers, so it has to be those ones. And I'm going to times them together. 15 times 12 times 4. $720.
And isn't it 72 litres?
Not quite. So that's centimetres cubed. Now remember when I was holding my hands out showing how big things are? A centimetre cube is this big. How much is it in capacity? A centimetre cubed is the same as a milliliter because they're little ones. So I could say straight away that that's 720 millilitres. Now it's a capacity, but it's not the capacity unit that I want. I want litres. So how do you change from millilitres to litres? And I drew this diagram way back here for you. Millilitres to litres, you follow the arrow, divide by 1,000. So at the end of this, you go divide by 1,000. No, 0.72. Type it in again. So just 720 divided by 1,000. There you go, 0.72 litres. Okay, that wasn't too bad, was it? Good, all right, last ones here are practice converting. And it's a mixture. We've got centimetres squared, they're areas. Oh, I can't do a centimetre cube to a... This one, they would both have to be threes. I can't do 1 squared and 1 cube, that's not going to work. So let's change those both to threes. And then we've got some capacity units down the bottom here too. All right, so starting with A. 0.5 centimetres squared, and I want to go 2 millimetres. If I'm just thinking from centimetres to millimetres, do I times or divide? Yeah, because millimetres are smaller. And what do I times by? How many millimetres are in a centimetre? 10. 10, just 10. So that's that chart. Go back to it. Oh, it's going to go really slowly apparently. This chart. We're at centimetres cubed and we want to go to the millimetres, so we're timesing by 10. But because it's volume, it's going to be 10 cubed. So we put a power of 3 on that. Okay, now these conversion charts are on the back of your formula sheet. So maybe turn those over. See yours there, Kobe? If you turn that over, there's your conversion charts there. Okay, so what is 0.5? So 0.5 was our number, and we have to times it by 10 cubed to the power of 3. That's right. That's right. So this is 500 millimetres. Oh, no, I did cube. This is meant to be area, sorry. Go back, go back. This should be squared, so I'm doing an area one. So what should it be if it's a squared? Yes, it's 50. I put an extra 0 on that I shouldn't have. There you go, 50. Because they were squared, squareds here, these squareds mean I square that 10. In the next one, when I have my power of 3, this is when I'll do a power of 3 for this one. So look on your chart. How do I go from metres cubed to centimetres cubed? Look on your chart right in front of you.
Yeah.
100 what? 100 cubed. Good. So let's type this in. We go 0.007 times by 100 cubed. And we get 7,000 centimetres cubed. And that one was squared, millimetres squared for the first one. It's easy to mix them up. You've got to be very careful with those powers. Part C, this is the capacity ones. So again, you've got those in a box down there, or you might want to draw, remember that I only have, on the sheet, I only have the milliliter to litre one. You might want to draw the one that I just gave you in the booklet on there as well. You can add that to your sheet. How do you change from millilitres to litres? Flick back in your booklet to where we talked about capacity. How do you change from millilitres to litres? See what it does? Not on that one. In your booklet, Kobe. Go back a couple of pages, go back a page. Where we did the capacity. How do I change from millilitres to litres? All right, I'm going to have to go back. Here we go. This one, this thing here. So do you guys want to quickly add that to your study sheet on the back? So next to that box on the bottom where you've got the centimetre cubed equals a milliliter, draw that little diagram, please. Is it on yours? No, this one's not on there. You've got the centimetres cubed equal a milliliter, and the metre cubed equals a kiloliter, but you don't have that in the conversion chart. So our question was, we want to go from milliliters to liters. Follow the arrow. What do I have to do? Times or divide? Divide by 1,000. Good. What is 3? 3.5. Yes, 3.5 litres. Good. And the next one, we have kilolitres. So put your finger on the kilolitres and follow the arrow to litres. What do I need to do? Times by 1,000. So that's going to equal 2,700 litres. Right, so that is it. It is.